This video is entitled Third Normal Form. It is the third in the three-part series on database normalization. I'm Jim Renault from Shawnee State University, and I'll be taking you through this video presentation. In this video, I'm going to define what third normal means, and I'm going to show how to get data from second normal to third normal. Be sure that you've watched the first normal and second normal videos prior so that you can watch the steps and watch the examples as they move through the three videos. What is third normal? Well, third normal is the third part of normalization. Now, your data has to already be first normal and meet the 5 criteria. Your data also has to be second normal and have partial dependencies removed, because what we're going to do in third normal is we're going to eliminate dependencies known as transitive dependencies. Transitive dependencies are dependencies that exist between two data elements in a table. They exist between two data elements that one of them isn't part of the primary key or the primary key. So if you've got two elements that are related to each other that aren't part of the primary key, that you didn't eliminate in your second normal, third normal is where we get rid of all of those transitive dependencies. So the data shown here is our customer example in second normal form. We were in first normal, second normal, there were no partial dependencies, so we're now in second normal. Let's identify the transitive dependency. Well, I've marked the transitive dependency here with the arrow because a salesperson's name is not really dependent upon the customer number. It's dependent upon the salesperson number. So the salesperson name is dependent upon the salesperson number. It's a transitive dependency. It's dependent upon a different entity. And so we can eliminate that in the next slide. So here we eliminated that salesperson transitive dependency by removing the salesperson name and creating a new table called salesperson. And we have the salesperson number and the salesperson name. It's dependent. There are no partial dependencies, no transitive dependencies. We didn't create any new partial dependencies or transitive dependencies by making this change. So we're now in third normal. Remember, whenever you make a change, you need to go back and make sure it still meets the 5 rules of first normal, and you didn't create any transitive dependencies by moving things around. So we're now in third normal form. This is a pretty good database structure. This one would work. And it looks something like this. Notice that a salesperson can have 0 or more customers. A customer has one and only one salesperson because every customer had a salesperson. A customer can have many phones, but a phone belongs to only one customer. The foreign key salesperson on the customer is the primary key on the salesperson table. So you can see there how our 3 tables now relate in a nice, concise entity relationship diagram. Our second normalization was the purchase order. And when we were done with second normal form, we had 3 tables. We had the product and the purchase order detail table. Now, the easy transitive dependency that just jumps right out at me would be the vendor number to vendor name. Vendor number 7 is XYZ Supply, and it's not dependent upon the purchase order number or the product number or anything else. It's dependent upon the vendor number. So let's go ahead and make that transitive dependency go away by creating a separate vendor table. So we created our 4th table, the vendor table, and I kind of look at the data and go, there's this dependency that's kind of transitive, that's kind of partial, that's kind of just a weird one, the vendor product number. Now, the vendor product number would be the catalog ID that the vendor uses for our product. So we call it this, but one vendor calls it that, another vendor calls it something else, another vendor calls it something else. So the vendor product number is really dependent upon the product number and the vendor number. And I could have drawn that dependency to the vendor table if I'd have wanted to, instead of to the vendor number in the purchase order table. But because they're dependent upon each other, it works out either way. So I think that there's a dependency that I need to go ahead and eliminate, and that's kind of a partial dependency. It's kind of a transitive dependency. It's kind of one of those kind of oddball dependencies, and you just got to look for them. You just got to spend time and look for these things and make sure you understand what's dependent upon what and what the business rules happen to be that go along with it. So I'm going to go ahead and eliminate the vendor product number out of the purchase order detail and create a new table for it also. I now have our purchase order and purchasing information in third normal form, and it took 4 tables to do it. 5 tables to do it. It took a product table that has product number and product name. It needs a vendor table with vendor number and vendor name. It needs a purchase order table with the purchase order number and the information about the purchase order, including vendor number. There's the purchase order detail table that contains the purchase order and product number and the quantity of that product, the detail of on that purchase order of the products and what we bought and how many. And then the vendor product table connects the vendor to our product. So if I know the vendor product, a customer calls and says, yeah, I need a 4421. I think that's somebody else's number. I can look that up and go, oh yeah, 4421 is our product, BW. Kind of nice, right? Because that way you could do a vendor cross-reference of look. Somebody says, I know this vendor number. You can go to the vendor product table and find out what product it is. Or if you're ordering a product and you're ordering it with this vendor, it'll tell you what the number is. So it makes it really convenient to have that and to split that out into its own table. Let's look at the ERD. I believe the entity relationship diagram would look something like this. Let's look at a purchase order. A purchase order has one vendor. A vendor has many purchase orders because we may buy lots of things from that vendor. A vendor has many products, but a vendor product belongs to only one vendor. A purchase order can have many detail items, but a detail belongs to only one purchase order. And a product can be on many details, but a detail is for only one product. Remember, there's a many-to-many relationship that we would have done in the subject area model between purchase order and product. A purchase order can contain many products, and a product can be on many purchase orders. And we've eliminated that with the purchase order detail table in the middle. And we've now eliminated all of our transitive and partial and that one funky relationship, and we've now got it into a nice third normal form, and we can actually start thinking about implementing something like this. Let's look at our third example of the package shipping company, Gem Ship. We lose things. So we're in second normal form here, and I'm looking around and I say, yeah, there's a transitive dependency, all right, because there's a transitive dependency between activity code and activity. That's certainly a transitive dependency we can eliminate. Now, could we eliminate the transitive dependency from zip code back to state and city? A zip code belongs to one state and one city. Well, that's sort of right, but not always. There are sometimes different city names that use the same zip code. So while we probably could just store the zip code and make the zip to city a transitive, get rid of that partial dependence or transitive dependency, I'm not going to do that. But I do see the transitive dependency here of activity code to activity. So let's create an activity table and eliminate that transitive dependency. So you can see I have an activity table. I remove the activity description from the package activity table. And now let's see what the third normal form entity relationship diagram looks like. Here's third normal. A package has many activities. An activity belongs to only one package. An activity code has many activities, but an activity belongs to only one activity code. I say here, in a lot of the other examples, I use 0 or more, but here I use 0 or 1 because a package can't exist without at least one activity. So that would mean that, and I think I copied that relationship. It makes no sense to have an activity defined that we haven't used on a package yet. I guess that could have been 0 or more. And if you'd have drawn the diagram with 0 or more between activity and package activity, I would have said, that's okay. This concludes our brief introduction and demonstration of third normal. You got to watch all three of them together, first normal, second normal, third normal, to really get the feel for database normalization. This video was copyright 2020 by James M. Renault, PhD. You can contact me at jrenault@shawnee.edu. Remember, this work is licensed under Creative Commons Attribution, Non-Commercial, Share-alike 4.0 International License, and I want to say thank you very much for letting me have your time.